Hey Kata, wanna be a constexpr?
Are you okay? Do you need me to send an ambulance?
No, I'm fine. I'm fine. The pun works better on
Okay, better.
text. Wanna be a
Okay then.
constexpr expert?
Uh, oh no. This is another quiz episode, isn't it?
Yes! Let's start from the beginning!
Oh no. Okay, I see that you're very excited. Cool down a bit.
Hey folks, you know the drill? You have a link here and in the description.
Close the video, take the quiz, and come back when you're done.
Hey, how did it go? Leave a comment down below with your score.
Now, let's get our hands dirty.
Okay, so again, this quiz is about constexpr. So you guessed it. What does constexpr mean in this context?
Uh, it's easy, it is true.
Yeah, I mean, it's just saying that an expression needs to be evaluated at compile time, its value cannot be changed at runtime, and well, this was introduced in C++11, so before that means nothing. Well, it's a compilation error actually.
Uh, okay.
So what's the
Then,
type?
then, then. Costful.
Yes, constexpr, it's not part of the type. It's part of the expression. A type cannot be constexpr qualified. So the type, because it's not mutable, is const foo.
Okay.
What does it mean in this
Then
context?
all the correct answer is this one.
Yeah, I
All.
mean, this doesn't mean that it's going to run at compile time. This means that it's constexpr compatible, so you can use it inside a constexpr expression, so a constant expression. It tells you nothing about the arguments and tells you nothing about the rest. It's just that this function may be used inside a constexpr. What about this one?
Confess. Confess. Do you like select all answers where the response is only one?
Yes,
Nothing.
I love it. So yeah, I mean, you again, const expr is about an expression. In here, that's a type qualifier, so it means nothing. It's an error. You cannot use it in this way.
Okay.
What about here?
And we have this.
Yeah, I mean, it literally means that this if statement needs to be evaluated. I mean, that the expression needs to be evaluated at compile time, and so if it is false, it will skip do something. It's important that do something still needs to be syntactically correct. I mean, it's not like an if and def or other ways of deleting code using macros. The code needs to be valid, but it will not be run. It will not even be compiled at that point if at compile time it evaluates to false. Again, this was introduced with C++17. Before that, this will fail to compile.
We like the next questions.
So
This one. Is this one.
yeah, constexpr was introduced in C++11. And fun fact, in C++11, the limitation was that constexpr functions needed to have one single statement in them, and that statement must be our return. So what about this?
And this one.
You sure about that?
No, I'm not sure about that. It's also
Yes.
this one.
Well, the rule was simple. The rule is one statement, it needs to be a return. And this is the fun part. If you give a ternary operator to a programmer, it will use it to get around the limitation. So as soon as they people figured this out, they started building really complex functions with ternary operators and recursion and all the stuff to get around the limitation. What about this
Grammars.
one?
And now I'm sure it's this one.
Yeah,
I
after
can't
C++
confuse me anymore.
11, after C++11, they figured out, well, if programmers are going to get around limitation by just using ternary operators and all these things, let's relax this a bit. And so from C++14, you can have more statements in a function. You can add variables and all of that. You can just go and write a more or less normal function. There are still some limitations, but you can now use some more advanced syntax.
And here you're scaramantic because you skip 17.
Yeah, I mean,
No.
from a constexpr standpoint, C++17 introduced little to nothing. I mean, there were some quality of life improvements, but nothing major. And the huge thing here is that up to 17, you could not allocate memory in a constexpr. I mean, you allocate memory at compile time, so you couldn't do it. And so std vector or anything that needed to call new or delete was incompatible with constexpr. So in C++20, they removed the limitation, and now you can use std vector or std string or anything that actually allocates memory at compile time.
Not bad.
What about this?
No, this is not valid.
Yeah, there is still a limitation. Any memory that gets allocated at compile time remains at compile time. It cannot leak out. It's like Vegas. If you allocate memory in Vegas, stays in Vegas. So otherwise, it's not actually a memory leak, but it's more of
about,
what?
Did you know that personally about Vegas?
I don't know. Whatever happens in Vegas stays in Vegas. So, yeah. So the problem here is that we are returning the vector, and the vector allocated memory potentially, and so this is against the rule. You are leaking the memory that the vector did allocate and is owning. You're trying to leak it outside of the constexpr. So this would not work. I mean, you could use it in a non-constexpr context, but if you use it in a constexpr, it will not compile.
Okay. Then, okay, here we have.
Yeah, this is
nothing before.
This is not constexpr. This is const init. So C++20.
Also.
Yeah, C++20
you
introduced
change also the meaning.
Yeah,
we're just talking about constexpr.
Yeah, I mean, it's all part of the same family. So in C++20, this was introduced, and it's similar to constexpr from when it's going to be evaluated, but it doesn't provide the same constness at runtime. So once it is initialized at compile time, this variable, now it's mutable at runtime.
It's a family like in Fast and Furious.
Yeah. A family.
It will be it's dangerous. Nothing.
Again, const init, constexpr, and all these things, they are not type qualifiers, so you cannot use them in arguments.
Okay. And yes.
Yeah. The only thing you're saying here is that the value 5 must be known at compile time, and then you can return it. That's totally valid.
Okay. And then no.
Const init has some limitations, and leave a comment if you want to get into these details in another episode. But TLDR, const init needs to be either a global variable or it needs to be, well, a static variable in a function in a class. Well, at the end of the day, it's still a global variable, or it needs to be a static thread local, and in order to be initialized at compile time. Otherwise, that's invalid.
And please leave a comment. We really appreciate. Carlo, very appreciate.
Yeah, I love it. I love them. So, new
Also to
one,
prepare
consteval.
an episode about that. Yeah, and is nothing.
Yeah, I mean, consteval cannot be used on expressions. It's just about. I mean, it's confusing because constexpr is constant expression. Consteval is constant evaluation, but it sounds like the same. But no, this cannot be used on variable constant definitions. What about this one?
Okay, then this, and this.
Yeah, from C++20, consteval on functions is doing what people thought constexpr was doing in the past. So it's saying that the function must run at compile time. It must can be used in a const expression because that has compile time, but even if you use it outside, it's still going to be evaluated at compile time. The arguments at this point, if it must run at compile time, the arguments must be known at compile time. And I mean, this was introduced in C++20, so, well, before that, compilation error. What about this one?
Nothing.
Again, all the const something family, it's not a type qualifier, so you cannot use it for function parameters.
Yeah.
And last but not
And
least,
here we have this one. And let me say for the last time, nothing before the version 20 of C++.
yes. So this one, it's totally different from if constexpr, because if you see there is no expression actually. And what this means is that you want the code inside this if to be run only if this is a constant, it is being evaluated at compile time. So effectively, it is part of constexpr or is inside a consteval or so on and so forth. And this is useful inside constexpr functions to have different implementations depending on if they're running at compile time or at runtime. Because due to limitations that we discussed before, maybe you want to do some things only if you're running at compile time or some things only at runtime. And well, again, it was introduced in C++20. Before that, it meant nothing.
Okay, and now rullo di tamburi.
Ole! As always, if you like this episode, like, share, and subscribe.
Okay, and feel free to leave a comment to suggest other topics or keep the conversation going.
See you next time, folks.
Bye.